Hello everybody. In this video we're going to start working with Delegate. And this chapter of the book is actually really complex, it's really big. There has Delegates, events, and Lambda. Probably I will talk a little bit Delegates today, and a little bit of Lambda, and probably I will keep events for another video. So the thing is what I want to show you is a quick example what Delegate is and how you can actually use it and how it can actually save you to write code in your application. So a delegate, pretty much what it is a method that runs another method. Not straightforward, but it has like an assignment that is pretty much inheritance the functionality of another methods. I know they sound a little difficult to understand to see it, but let me actually show you. So I have Visual Studio Code open. I'm in the folder where I want to save my project, and I will do .net new console, and let's save this as delegate demo. Okay, we open delegate demo in this application, and I had it right there. Perfect. Let me fix the sizing a little bit. Okay, we need to do yes to here, and then the sizing. This one we can close it actually, and we can do something like this. Perfect. So we have a simple program. All right, the hello world there. So let's do. Let's do a new C class. Actually, let's keep the same one. Let's do everything through here. So we have the name set delegate demo. We have the hello world is actually working. Let me open my terminal, and we do .net run. Okay, that's there. So actually, a delegate is a function signature and type without implementation. And let me show you a little bit how to actually work in the system. The first thing that we need to be doing, we need to declare the delegate, and we can actually do that right here. After the class program, let me do public delegate, and let's do a void function, and let's say this was my delegate. So we do first a declaration. This my delegate will hereby the delegate property that then we need to create an object or a property that actually will to that delegate. So let's actually initialize it with, and we can do a private. Let's do private my delegate. That's going to be the type. And let's call this my delegate in lowercase. Perfect. So now we declared my delegate, the type of my delegate, and it's just a simple program that will be handled later. So in order to make this work, we can do something like this. Let's create another method function. Let's do a private void. This function needs to have the same signature to my delegate. So my delegate doesn't have parameters. As income and is a void, so we need to do the same. So we do something like void say hello, and we do simple console dot write line hello there, right? Can do something like this, and then in order to make it work, now that we have my delegate, we can actually assign it. So we can actually do my delegate, and it should be in delegate with lowercase m equal Let's do a say hello. And now that we had it like that, we can actually just execute it. So we do the assignment, as you can see. We have an issue. What is the issue? And object require. Okay. The problem with saying that it's a non-static field method or property. That's because the main is actually static. So the way to fix it is you just remove the static from the main, or we add the static to the other two functions, right? We have to delegate that one. So yeah, we fix it just like that. So that's a simple that we can actually do a simple my delegate and execute it, and let's see what the output. .NET run. Um, oh yeah, it requires the static. So let's put the static here, and let's create this one to be static private and this one to be static private. Remember, it needs to have the same signature in order to make it work. Let's do it like that. There you go. Hello there. So the delegate was able to execute say hello. We didn't execute say hello directly, so we delegated the execution to my delegate in this case. So we are able to do that. The cool thing is we can actually have a second function with the same signature. And let me save this. Let's call this say goodbye with another implementation. Goodbye there. And we can actually do my delegate equal say goodbye. And then we execute my delegate again. We will have the goodbye there, right? So the same delegate, we did two different assignments, and we were able to use it because we have the same, how can I say, the same signature. The signature in this case is static, private, a void element. So we just did the same, and we are able actually to use this in this particular case. Now, this kind of implementation is the fundamental for the events. We can actually have several functions that are going to delegate, and they work something similar. So let me just do a simple example. Let's put this one over here, but instead of saying equal, let's do a plus equal here, and let's remove this one from here. In this case, we delegate, we put a say hello, and we added say goodbye, and we execute it. We will see that box function getting executed calling my delegate only once. So that's the way that actually you can actually subscribe and unsubscribe events in the future. And I will show you the event part. That's what it uses in the underline, pretty much using the delegates in there. So something really cool about this and this kind of assignment is that actually we can do the other way around. My delegate mean equal say hello, for example. And if we execute this one, we're going to see first both of them and then just the goodbye again. So we're able to add and remove element in this case because we're actually calling those or adding through the delegate elements. So simple enough. Other thing that we can actually use, let's create a second delegate. Let's do public delegate. And let's do this one to return actually an integer. And let's call it another delegate. And let's say this actually get a parameter of integer. Right? We want to be sending something there. So we are having something that go in and it will return a value itself. So we can actually create a new function. Let's call this static private integer. Let's call this double. and it will receive integer number. Let's call this number. And let's say, actually, let's just do this way. We will return number multiplied by 2. Right? This should work in theory. And didn't like it. Why didn't I like it? Oh, because I put it twice. Oh, I cannot use the word double. Oh my god. I forget about this. This is a reserved word, so yeah, no, it cannot be used. Um, let's call this 2x. So we receive a number and we send the number. So we have that function, right? They have the same signature. So we can actually initialize the another delegate, call it static private another delegate, and call it another delegate. Right? Let's comment this out. And let's put as simple as another delegate is going to be equal to x, and I can just execute another delegate with value 5, for example. And let's do a simple console.writeLine this particular. Let's save it. Let's execute. And we should receive it at 10. There you go. So that's what, okay, we have a warning because they say that my delegate was never used because we just comment this out. So let me just to have it there. Let's put that one there just to remove that warning. There you go, and we have that. So the same way that we are able to do a delegate that is void without parameter, we did another one that return an integer and use an integer as input. Now, what is important here is say that this name doesn't matter, that doesn't match the name of the function itself. So in the function, we actually call it as number, and here we call it as I, right? In that case, it doesn't matter, but we are keeping the same signature, that is the same value. So we're actually getting that one over there, and that's why it allowed us to proceed. In this case, if we send 5.0, we should have an issue, right? Because it's actually expecting to have the integer there instead of a double. Okay, let's save it like that. Let's do another example now. So what this is doing actually in the background, in order to make it work, is in reality, is saying my delegate is actually equal new my delegate, and we send the function as parameter. Well, it's pretty much this is what we're doing, right? But we can just assign it just the function directly, and it's a shorthand for having that one. Okay. Another way to do it, and let's do it through this one, and we can actually send it through an untitled function. So an untitled function is something that a function that we can actually execute in our code without having to create a new block, something like this. So let's actually put this one. Let's create the another delegate. Let's actually do another implementation and both having the same signature. So let's do, in order to do another function, we just need to use the word delegate, and then we just do function here and the function content, right? In this case, we need to send integer I is a simple number, and you can actually return, in this case, let's return I by I. This is a square function. So if we do something like this, and we execute it, it didn't, it fails. Why it fails? Oh, Missing this one here. There you go. I was missing a semicolon here. So let's try it again. There you go, and we have 25 now. So we create another function that is an anonymous one, and it actually takes the parameter, and it allowed us to actually have this one over here working the way that it's supposed to, right? Now that I have that, I didn't like that I actually needed to delete the other one, so let me just put the other one back. Let me just return. We have that one, perfect. And then we can actually create this one. So I change the assignment, and now I actually do this anonymous function. So one of the biggest benefits of that is, instead of creating a new block with that particular function, we can just put it in a single line. That helps us a little bit with readability and save you lines of code. That always beneficial when you're developing something. So let's do another anonymous function here in this one. Let's actually call the first one my delegate going to be equal, and let's say delegate function, and the implementation, let's say something like console dot write line. Let's say I don't know, who let the dogs out. We save this one over here, we do this one over here, and when we execute my delegate, this actually working the same way, and we have the same signature that we declared on the top, and right here with the void. So let's do this one, and we should get who let the dogs out, and the number 25, because this one. Perfect. But those are actually not the only type of function. You can actually do Lambda function. A Lambda function is a minimized version for this one, and we actually use some similar already in the past. So let's put this one over here. Let me create another one, my delegate, and I actually can add it. So let's actually put it over here, and let's do a Lambda function. So in order to make a Lambda function, we use a star with the parameters. In this case, it's an empty parameters. Then we do I call it the fat arrow. I don't know what is the official name. Equal greater than that symbol. And then when we don't need to return anything, we just put inside the curly brackets, and we can do console dot write line who and we do it. Of course, I'm missing my semicolons. There you go. So who let the dogs out? And we have the second answer there. So we're able to put it through an anonymous function, and we're able to put it through a Lambda function. As you can see, Lambda function is a lot shorter than an anonymous. Well, not that much, but it saves us some kind of implementation. So Lambda function, as you can see, those really streamlined functions that you can actually define that work as an anonymous one without having any kind of implementation. And we can actually put it right here. And it's pretty neat. Also, as you can see, we're able to assign it and add it to my delegate. So when we execute my delegate, both of them get executed. We can actually pile different functions on top of that, and we can have several. The only issue with this kind of implementation is that it cannot be removed later. Something to get ahead, because it's an anonymous Lambda one. If you want to be able to remove something later, like when we do the hello over here, just do the traditional block for the function, so you can actually be able to remove it on demand. So let's do another Lambda function now for another delegate. That one that actually needs to return something. And let me show you the benefit of that. So let's actually do another delegate. And we can pile it up, as I said before. And let's do a lambda. In this case, let's do an integer. It need to have the same signature. That's really important. And then we do the fat arrow. And we can just do what we want to do it. So in this case, let's actually return the same. I multiplied by I. We save it. And it's a lot shorter here. If we execute it, we should saw the 25 twice at the bottom. Why didn't have it twice? We're supposed to be... Oh, because we have the same functionality. Let's actually do this one by 3. Let me change something here. And let me try it again. Oh, interesting. Somehow another delegate is not allowing me to pile up new ones. Let me have something like this. Let me see what's happening over here. Oh. It looks for delegates for the one that actually returns something. It's just keeping the latest one instead of doing the whole... Oh, I know what is happening here. It doesn't... Okay, yeah, I know what is happening here. I'm just printing this one and it pretty much gave me the last iteration because I'm saying right line. So let's actually do something simpler here. Let's do simple array. Right, let's actually do it through here. So array, and we call it this my array. And let's call it integer. Let's see if this actually works. And our delegate, what is doing it? It's really weird. No, it didn't work like this, the way that it's supposed to. So let's keep like that. So in this case, because they need to return something, and the implementation is not directly straightforward, as I imagine. So the last one is actually taking care or taking everything for that one. Sometime I will let me investigate that later and probably put another video explaining this. But for now, you saw pretty much how you can actually do delegates, how you can pile it up sometimes, in this case, and having different delegates having without anything implemented or returning a specific value. We did it through a code block, we did it through an anonymous function, we did it through a Lambda function. And all of them actually work the way that we're supposed to be doing. Now, there are some extra implementations that we can actually use. There are some wrappers for those empty and the one that need to return something called action and func. Action and func will allow us to have a little more streamlined code, and let me show you that. So let me show you those ones. Those ones are actually inside system. And let's do it right, we can do it, let's do it right here. No, after this one. So let's do private action. And let's say my action. And this action, what it is, and we can actually see it, it's pretty much a system action, it's a delegate void. So action is pretty much just a wrapper of this one. And the cool thing is we can actually have a type too. So we can actually do another like private action, and we open something like this. We actually say what kind of type. Let's actually do some boolean, and let's do some string, and we'll put another action, right? So this one will be a delegate that take two different arguments. Those arguments should be a boolean and a string, right? And let's implement those. Let's implement those where. Let me try to make the code a little bit smaller so you will able to see a little bit more. So probably you should be able to read there. Let's implement those right here. After this one, and let's do a simple action. So we call them my action. And let's do my action is going to be equal. We can do the say hello. Oh, we have an issue here. We'll have the issue. Oh yeah, action needs to be static because we have a static over here. So let's do static, and this one should be static too. There you go. So we have my action. I say to say hello, and we execute it. We should have a say hello at the end. Let's try to run it. I don't know if you can see it, but yes, you have the hello there, right there. And no, it's too small. Let's make it bigger. There you go. So having this works, we're able to do pretty much the same through an action and do that. So that will, the action will pretty much save us to create an empty delegate, something like this. Also, I was saying that we can actually send different elements. Let's do another, the other one. Let's do another action. Is going to be, let's send bool value, val, and let's do a string text. And let's do a simple, but this is not returning anything. So we do something like this, and we do a console dot run line, and let's do formatted, and let's put the boolean is, actually no, let's do it something like this. And we're going to send the text and the boolean that's going to be called ball. Put the one over here, we do that one over there. So with that, because it matches the same action signature that I have here, we can actually execute it now, and we should be able to see the text. And let me send here true, and I need to send a string called the boolean is, something like that. I should be more than enough. So we should be hello there, and the boolean is true. We're able to see that one right there, and let's remove this extra line. Oh, so we're able to have an action for that kind of information. Now, the same way that we have an action for those, we can actually have something that grab when you need to return a delegate and return something. So and that one is actually a function. So let's do a static, private, let's do func, and in this func, it has something, let's call it my func. right? We need to define what is going to be returned over here. So in this case, let's do it. Let's put this one. It needs to return an integer, right? If we save it, we should be fine. You can see the result is actually an integer. Now, there are several implementations, and we can have any quantity of parameters here, but the last one always need to be the one that you need to return it. So in this case, let me put another integer. The first one is going to be an input, as you can see, int out result. So we can have several, I believe 13, 30, I don't know how many. And the last one is going to be this. So with this program, my func, we can actually do something like this. My func equal integer I, and we're going to return I by I by I 3 times, right? And we just can do simple call it with, in this case, number 5. No, let's actually do number 3. And let's do a simple console dot write line, that one. Okay, so we should empty, I believe 27 should be the output from this one. If we do it, there you go, we have 27 there. So with this one, we actually did the function is just a wrapper for a delegate that returns something, and action is a wrapper for a delegate that doesn't return anything at all. So with that, I believe we have all the delegates. There are several opportunities to use them through the code, and we can actually add them. But I see a little more beneficial using events most of the time. And in the next video, I will show you how to actually use events in a fake application. So far, I hope that you like it. Any question, any doubt, don't hesitate to reach me. Happy coding, everybody.